Let's take a look at the mean value theorem. The mean value theorem says, let f be differentiable on the open interval AB and continuous on the closed interval AB. So the key thing is we have to have a differentiable function, got to be able to take the derivative at all points, and it needs to be continuous as well. So if we have a differentiable and continuous function, then there is at least one point C between A and B where f prime of C equals f of B minus f of A divided by B minus A. So this would be, you'll recognize this as the slope of the secant, or the average on the interval from AB. And this here is the derivative, the instantaneous slope. So if we take a look at this one here, this graph that we've got here, let's say this is f of x. The slope, the average slope from A and B, of course, would be this line right through here. So this slope would be the slope of the secant line, which is f of B minus f of A over B minus A. And there's got to be at least one point on there that is equal to the slope of the secant line. So you can see that there would be a point like right here. Apparently that's a rainbow color here. Let's get more of a solid one. I was kind of hoping for blue. We'll go blue. There we go. So this would be our point C right here. So if you have a graph that's continuous and differentiable, then the average rate of change is given by the slope between the two endpoints. There will be at least one point between A and B where you are doing the average of that interval. So let's take a look at an example here. Here we have a function, f of x equals x squared plus x. Verify that the mean value theorem is satisfied and find all values c in the interval between -4 and 6 that satisfy the conclusion of the theorem. So the very first thing we've got to do is say, is this a differentiable and continuous function? The answer is yes. This function is differentiable and continuous because it's a polynomial function. Okay, so then let's find the slope of the secant line. So that would be f of B minus f of A divided by B minus A, which is f of 6. So this would be 6 squared plus 6 minus -4 squared plus -4. So there's f of B minus f of A all over B minus A. And this would be 42, 36 plus 6 minus 16 plus -4 would be 12 divided by 10. So we get 42 minus 12, which is 30. 30 divided by 10 is 3. So we've just found out that the average slope between -4 and 6 on this thing is 3. There's going to have to be one point on here that is equal to 3 when we take the derivative. So let's find the derivative. That would be 2x plus 1. Let's set this thing equal to 3. Whoops. 2x equals 2 at x equals 1. So find all values of c that satisfy the condition of the theorem. We would say when x is 1, the slope of the tangent line, or the instantaneous rate of change, is equal to the slope of the secant line, 3. So when x is 1, we have a slope of 3, which is the same as the average between -4 and 6. So that's the mean value theorem.